Hi, welcome back. Now we are going to again look at a table. So here is the table where this question would have given you, and you want to talk about the trend in the data. So a lot of times you're going to be asked to describe the trend, whether it's increasing, decreasing, and what you see, like the other examples. Otherwise, you might also want to pick a model that best represents it. So, what I need in your notes is the following. So, this first section, as we go through the units, we're going to add to our types. But for the most part, we have three different types. You have linear, which is what you are very used to. And that's the first type. And I'm going to show you, because we are working with desmos at home, I'm going to show you how the desmos calculator works in. So in order to represent linear, you're going to be looking for the y1 with this squiggly line. M, you guys are used to mx plus b, but instead of just plain mx, we're going to have mx1 plus b. This is how the linear regression is going to look. Okay. We also are going to have a quadratic, and you can see this example is showing the solution, and you could tell it's a quadratic, but when we go to Desmos, we are going to look at why it is a quadratic and how you're going to know what is the best. So to review quickly, linear is your straight lines, quadratics are your parabolas. Now, a lot of times, remember in real life, negatives don't really make sense. And if negatives don't make sense, then you're going to see half of the graph, which is what this is. So even though only the positives are showing, it does not change it from being a quadratic representation. It is still growing and following a quadratic pattern. Okay, it's just showing half of the graph because in real life, a lot of times, especially because this is talking about time, negative time doesn't make sense. So we're not going to show the other part of the parabola because it just doesn't make sense. And this is going to go back to your algebra 2. You learned how to do an algebra 2. It's called the vertex form. So for our regression, we are going to look at it in terms of the vertex form. Now, you could use standard form. However, with standard form, that's not really what your book is doing. And because a lot of the questions in your book are based on this form, vertex form, is I'm going to show you how to put the vertex form in Desmos rather than show you how it would look in standard form. Okay, so that should be okay. Sorry. So this is your regression and what you would type in Desmos if you wanted to see if it was a quadratic. Okay, that's your vertex form. Last but not least, and I'm going to write over here, is your square root function. And writing with a mouse is not exactly pretty, so I do apologize for that. Usually I like to use my iPad for these videos, but I can't do Desmos on my iPad and be able to screenshot it. Okay, so your square root function looks kind of like a rainbow. It is very similar to a log function, except it has a starting and end point, whereas log goes off infinitely in directions. So when we get into logs later, it's going to be really important on how closely we look at our regression line and our residuals, which I'll show you in Desmos. So for this one, you are going to have the y1, again, the squiggly line, and we're going to make it look similar. You're going to have the a out in front. Then you're going to do your square root symbol. Inside the square root is x minus h. Outside the x minus h is plus k, and this will give you a very close regression line that you will then be able to use later on. Okay, so if it is asking you to find a model that fits, these are the three that we are going to be looking at. And I guess we are going to have to do this possibly in two videos unless I can upgrade. So let's pause and find out.